Saxon Algebra 2, Lesson 15. The topic is elimination. As you recall, we recently reviewed substitution. Which is one way to solve a system of equations. Which is often our noble objective. And elimination is a second technique. It serves the same purpose. It helps us solve for x and y, or y and x. It happens in opposite order sometimes. But it is useful for different types of equations. So there is one example to this lesson. Let us dive in and enjoy every lovely morsel. Use elimination to solve. I reminded you that in the beginning, John is going to dictate which method we use, substitution or elimination. Once we get a little further in, you will be able to make your own choice. And we'll talk about good ways to do that when we get there. Actually, I'm going to talk about it in just a minute. Use elimination to solve. And then he gives us a nice little problem here. I have a daughter making probably a smoothie, probably not mayonnaise. And you can hear the immersion blender buzzing in the kitchen. Okay, so we are told to use elimination. It's not a choice for us, but elimination works when all four of the letters have a number in front of them. Remember, with substitution, we rearrange to get one letter by itself. If all the letters have coefficients, then you probably don't want to go with substitution. You want elimination. With elimination, what we do is we look down the columns. That's why we always write it neatly, and we always put our x's and our y's, or whatever letters you have, but you let your variables match up into columns, because what we're looking for is a way to offset these numbers. We're going to add these two equations. Remember that? We're going to add them together, and what we want is for one of the variables to cancel itself out. So what is lovely is when we have one positive and one negative, and that's what we've got here. Okay, we've got a 3 and a 2. Those numbers aren't going to cancel themselves out. We have a way of fixing it, but in this case, we'll have to adjust both of these, won't we, to make them 6. We'll make this one positive 6 and that one negative 6. And we can do that, but that will work better than this. We would still have to adjust over here because we still have a 2 and a 3. They've traded places, but we would also have to multiply this one by 3 and this one by 2, but we'd also have to change the sign, which I don't like to do. I don't like to mess with the signs if I can help it. So I vote that we work here, and I like to make an asterisk there. We're gonna adjust the x's so that they cancel out. And I'm going to use another color to help you so you see this. We're going to multiply this one, every part of this equation, we're going to multiply by 2. And this one, we're going to multiply by 3. Then we'll have positive 6x and negative 6x. And when we add the equations, they will cancel, and life is going to be fan-freaking-tastic. Just wait and see. So the first thing I have to do is that multiplication I talked about. And remember, we have to multiply all 3 terms. Okay, and same for this guy. It's always tempting to multiply like these guys and then forget them. Don't do it. Don't do it. All right, 2 times 3x, 6x, plus 4y equals 46. And then minus 6x plus 9y equals 6, all right? I'm gonna put this back on here to show that I've rewritten the entire system. Now we're ready to add them. I remember learning to eliminate and thinking, you can add together equations. That seems pretty reckless to me, but you can, and it's fine. When we go to add them, look, it happened just the way we wanted. That cancels. We get 13y. And we get 52. Ugh, those numbers might look a little scary, but if you know your 13 times tables, which I do a little, you know that 13 times 4 is 52. So that is going to cancel, and we're going to get y equals 4. Well, I feel good about that, don't you? So we've got part of our answer. Now what we do is, just like with substitution, we have to take this value and plug it back into one of these two, or it could even be one of these two. These usually have bigger numbers, so I like to keep the numbers as clean and simple as I can. This one's got a minus sign. I don't want to do that. I want to use the positive one. So we'll use that, and then I rewrite it plugging in 3x plus 2, and instead of y, I'm going to put 4 equals 23. This is 8, so I'm going to subtract 8 from both sides. 3x equals 15. I divide by 3, and I get x equals 5. Huh. Works for me. And then what we do is we write our answer, just like before, we write our answer as an ordered pair. X, of course, always goes first. And so it would look like this as your final answer. Yay! Remember, sometimes we can get away with just changing one of the equations. Like if this was 4x and minus 2x, we could have left the 4 and then just multiplied this one by 2, and we would have had minus 4. So you can adjust one equation, top or bottom, or you can adjust both. You can do the sign if you have to. You can put a minus in front of it and do that, multiply by a minus sign, but that can be kind of crazy sometimes. That just gets messy, so be careful with those. All right, lesson 15. I'm going to make this one short and sweet, and I'm going to say goodbye.